Okay, so today's notes are going to be on absolute value, and our objective is going to, or for content, our objective will be to write and solve equations and inequalities with absolute value. Our language objective is going to be to define terms like absolute value, extraneous solutions, and distance. So we're going to jump in by defining absolute value. So I'm going to write absolute value over here. And then on the other side, we'll do the definition and examples. So absolute value is the distance of a real number. We'll call x for now. So the distance of a real number x from 0 on a number line. And it is written as, so I'm going to put bullets here, so written as line, x line, or absolute value of x. For example, the absolute value of 4 is 4, but along those same lines, the absolute value of -4 is also 4. And I think the best way to sort of see and understand this is if you have a number line that goes from -4, -3, 2, 1. Make that a little longer. So if I have a number line that goes from -4 to 4, the distance from -4 to 0 is 4 units. The distance from 0 to 4 units is also 4 units. So the distance, while I didn't do this perfectly proportionally, the distance from -4 to 0 and 0 to 4 is the same for both. So since absolute value is the distance from 0, distance is always positive. You're not going to be negative distance away from something. So no matter where you are, distance will always be positive. So absolute value similarly will always be positive. So let's solve an example together, or an example of an absolute value equation. So we're going to start with what is the solution of the absolute value of 2x minus 1 equals 5. And I want us to also graph the solution. Okay, so the first thing we're going to do, step 1, is going to be to rewrite two equations. And one with a negative solution and one with a positive solution. So what that will look like is I'm going to take my 2x minus 1, and if I took the absolute value of that, it could be 5. So if I solve this all out in here, I could get an answer that is 5 itself. The absolute value of 5 would still be 5. But I could also get -5 in here, and when I took the absolute value, it would become 5. So what's inside the absolute value could equal the negative version of the solution or the negative version of the solution or the positive version. That's why you have to start with two equations, because you don't know if what's inside the absolute value would actually result in a negative or positive number. So then I'm going to, step 2, solve each equation. So if I start over here, I have 2x, I add 1 to both sides and I get 6. I divide both sides by 2 and I get 3. Similarly over here, I add 1 to both sides and I get 2x equals -5 plus 1 gives me -4. And then I divide both sides by 2 and I get x is equal to -2. So those are my two possible solutions. One thing that's going to be critical with absolute value is you always need to check each solution. So we'll see in an example shortly that sometimes when you plug them in, you do not get the same original answer. So if I plug this in, I'm going to have the absolute value of 3 minus, or sorry, the absolute value of 2 times 3 minus 1 is equal to 5. So then I'd get the absolute value of 6 minus 1 is equal to 5. So absolute value of 5 is equal to 5. That is true. My answer checks out in that instance. If I do the same thing with -2, I know -2 times 2 is -4 minus 1. Absolute value of -5 is equal to 5. That is indeed true. So both my solutions check out. That one's all good. So the last step, I got to graph my solution. That's what I'm going to do. I'm going to draw my number line and graph / plot the answers or the solutions. So in this case, I need to go from -2 to 3. So I'm going to do -3, -2, -1, 0, 1, 2, 3, 4. So my two solutions, my first one is -2 over here. So I'm just going to put a dot on -2. And then 3. They both are filled. It's just those exact numbers, so you don't need to worry about if it's open or closed. It's just those are the numbers. I can plot them, and that's my solution graphed. All right, the next thing we're going to talk about is extraneous solutions. So I'm going to flip the page. So we're going to do another example. It looks a little more complicated. So what is the solution of absolute value of 3x plus 2 equals 4x plus 5? All right, question mark. So we're going to try this one out together. Again, we're going to start with the same first step. So one, we're going to rewrite as two equations. And again, we're going to have one equal to a positive version of the solution and one equal to a negative version. So I'm going to have 3x plus 2 is equal to 4x plus 5. But I could also have, I'm going to draw a line here so we don't get confused, 3x plus 2 equals negative, open parentheses, 4x plus 5. So a negative version of the answer again. So notice that I just put the negative outside parentheses with that whole side. All right, now we're going to have the same second step. We're going to solve each equation. So when I do that, I'm going to move my 3x over here and my 5 over there. So I'm going to do this in one step. If you need to break it into two, by all means. So I'm going to move my 3x over here and then move my 5 over there. So then I'm left with -3 is equal to x. So that is my first solution. -3 is equal to x. Again, if you wanted to break that into two steps, by all means, please do so. For this one, I am going to first distribute my negative into my parentheses. So I have 3x plus 2 is equal to -4x minus 5. Then I'm going to add 4x to both sides and subtract 2 from both sides. So then I'm left with 7x is equal to -7. I divide both sides by 7 and I get x is equal to -1. So those are my two tentative solutions. So again, just like our last example, step 3, we're going to check each answer or check each solution. And I do that again by plugging into the original inequality. So I'm going to check x equals -3 first. So I'm going to write that over here, x equals -3, and I'm going to box in this process so you can see what I'm doing. And I have the absolute value of 3 times -3 plus 2, close absolute value, equals 4 times -3 plus 5. So this is the process of checking. I know -3 times 3 is -9 plus 2. Again, that's still an absolute value. 4 times -3 is -12 plus 5. -9 plus 2 is going to be -7. So I have the absolute value of -7 is equal to -12 plus 5 is -7. The absolute value of -7 is actually 7, not -7. So since it's an absolute value is equal to a negative, I know right away that that's not possible. So if an absolute value is ever equal to a negative number, then you know that that is an extraneous solution. So x equals -3 is not a viable answer. When I checked it out, I realized it does not actually work because I end up with a negative solution. So that's supposed to be like a no. That does not work, not an X, just clarifying. All right, so that answer doesn't work. Let's try our other solution. So I'll write this one, X equals -1. Let's try plugging that in. So I have absolute value of 3 times -1 plus 2 equals 4 times -1 plus 5. And then I get -3 plus 2, absolute value thereof, equals -4 plus 5. I get the absolute value of -1 is equal to -4 plus 5 is 1. The absolute value of -1 is indeed 1. That checks out. So that solution works. So my last step is going to be 4, disregard extraneous solutions or solutions that do not work, and box in the correct solution. X is equal to -1. All right, I'm going to cruise through a couple more things real quick. So another thing we're going to do today is absolute value inequalities. And I know this is a lot, so I'm going to make a little table with sort of like a cheat sheet of how to interpret these. Since there's a lot of sign switching and that sort of thing, it gets a little confusing. So we'll start with just the basic. The absolute value of X is equal to A. My solution set, as we saw in our very first example, if 0 is in the middle, my solution set will just be -A and A. And it's just going to be those 2 points specifically. So just dots on those spots, that's our answer. However, if we have the absolute value of X is less than A, or you could have the absolute value of X is less than or equal to A, your answers are going to be a bit tricky. And I'll show you an example that demonstrates this, or not this one necessarily, but demonstrates why these are a bit different in a minute. But your answers, again, if you have the same number line from -A to A, if it's less than, if the absolute value of X is less than A, you know it's going to be between, so between these two solutions. And if you can't see this, I'll darken this line. So your answer is going to be between -A and A. So if you have a solution set that you need to graph or show or talk about, it's going to be between two numbers if the absolute value is less than. So conversely, or on the other hand, if the absolute value of X is greater than A, or if the absolute value of X is greater than or equal to A, again, the only difference between these is if it was equal to, you'd fill in the circles. If it's just less than or greater than, you leave them open. Otherwise, it's the same. That's why we're putting those together. So similarly, if you have -A, 0, and A, these are going to go opposite directions. Sorry. So your solution set would be something like this. So it would be 2 separate inequalities, while this one would be 1 compound inequality. This would be 1 long string. These would be opposite. So if it's less than, you should end up with 1 3-part inequality. If it's greater than, you should end up with 2 distinct or different inequalities in different directions. All right, so let me do a very quick example. I'm going to actually do it as a quick check so you guys can try it on your own, since it's very similar to what we've been doing tied with that table. So what is the solution of absolute value of 2x plus 4 is greater than or equal to 6? So try this on your own real quick, pause it, go over it. Oh, I also want you to graph the solution, sorry. So if you have not graphed the solution, please graph the solution as well. I'm going to go over it now. I'm just going to write on the side our steps. So again, we're going to rewrite as 2 inequalities. An important note here, so let me do this first. So I have 2x plus 4 is greater than or equal to 6. Or when I write it differently, the negated answer. So again, when we do our 2 different inequalities, you're going to switch the sign. So just like when you multiply or divide by a negative number, when solving an inequality, when you choose or when you take out the negative answer, you're going to switch the sign. So switch the sign or the direction of negated answer inequality. So notice that I switched this sign when I negated 6. So just like when you multiply or divide by a negative number, you switch the sign. Similarly, when you take out the answer and make it negative, you need to switch the sign. I'm going to second step solve. So I'm going to add or subtract 4 from both sides. I get 2 is greater than or equal to 2. I divide both sides by 2, and I get x is greater than or equal to 2. When I solve this side, I have 2x is less than or equal to. When I subtract 4 from both sides, I get negative 10. When I divide both sides by 2, I get negative 5. So I have x is greater than or equal to 2 or less than or equal to negative 5. So my last step, I'm going to draw the number line for my graph and graph my solutions. So last step, I'm going to go from negative 6, negative 5. Okay, so I'm going from negative 6 to negative 4. I know x is going to be, I'm going to draw it a little above so you can see my lines better, though you should actually draw it on the line itself. But I'm going to do, or put my dot on negative 5, and since it's less than or equal to, I'll draw my arrow less than. Then I find 2. Again, it's a closed circle since it's greater than or equal to, and my line is going to be greater than, so that would be my solution set. And since they're pointing in opposite directions, I know I can't combine them, and that's my final solution. Sorry about that. So that's all we have for today. Make sure you write down any questions, comments, or concerns so we can go over them.